extended transition function. Extended transition function do exist for deterministic finite automata as well as non-deterministic finite automata. But in the case of deterministic finite automata, I have missed the explanation of this extended transition function. So today I'm going to explain this extended transition function in terms of non-deterministic finite automata, but the concept is the same. So if you're able to understand the extended transition function, in the case of non-deterministic finite automata, you can read with the deterministic finite automata. So let me take one example and explain this extended transition function. Okay, and then you guys might be seeing like some union operation here, some union symbol here. This. So let me just move straight to the example, and then I'm able to understanding these terms and all. Okay. Okay, fine. Now, let me draw. I'm going to explain extended transition function. I'm going to explain extended transition function, which is represented by transition symbol with this cape. Okay, this is known as extended transition function. And I'm telling you again, I'm using certain short here, function fn like that. You should not use such things in exam. I won't give any mark. I prefer shortcut in my class. I'm doing it. But again, in exam, please avoid this. And now, in order to explain this extended transition function, let me draw an NFA diagram. With that diagram, I'll be explaining this concept. Okay, Q naught, the initial state. So this one. Now, from this diagram, right, NFA, I'm going to explain extended transition function in context of NFA. This is NFA, and then as per this symbol being utilized here, this is double circle handle state. This one arrow mark is there, hence it's representing the initial state, and symbol with corresponding parts are being marked here. Now, I'm going to explain. I'm going to let me take one string here. W is equal to 0, 0, 1, 0, 1. So this string, right? How we are going to string with respect to this particular NFA? I'll be explaining that one using extended transition function. Okay. Now, extended transition function, right? How to check the processing of this one means, first, initially what we need to check is, we should start the extended transition function from the initial state. In this diagram, the initial state is Q naught, and then without reading anything, without reading anything, without reading anything where this particular transition will perform, that we need. Okay, so if we didn't read in the initial, if we didn't read any symbol, because epsilon is representing what? Null. So without reading anything, where we are going to perform the transition means it will remain in the same state. So Q naught. Okay. So we are checking processing of this one. So I've started from epsilon. I mean from null string. Okay. Next one is extended transition function. It should always start from the state. So I'm always beginning this one with initial state Q naught. As per this diagram, the initial state is Q naught. So I'm starting from Q naught. This is equal to Q naught, comma 0. Okay. I own you an explanation for this. When I started, let me put a number here. In step number 1, extended transition function, where to start? In order to check the processing of this given string 001 with respect to this figure or with respect to this machine, I have to start from epsilon, which is null. And then when I start from this null string, right, without any input, definitely the initial state will be the next transition state, and it is written here. Now, next one in step number 2, right, after null string, I'm selecting this symbol, 0. So, extended transition function initial state, comma, symbol 0 is equal to normal function, and then initially we started with this epsilon, right? The corresponding transition state is Q naught. So I have taken Q naught here and then 0 here. As per the diagram, currently state Q naught with the input symbol 0, there are possibilities. Either remain in Q0 itself or else perform the transition to Q1. Hence, the resultant state will be Q naught, comma Q1. Okay. And then step number, wait. In step number 3, let me do the step number 3 here. In step number 3, extended transition function should always start from Q naught, comma 0, 0. Okay, 0, 0 means I'm considering till here. Okay, 0, 0, 0 complete. So 0, 0, I'm considering it is equal to, see, previous to 0, 0, right, I have completed for this first symbol 0. Next one, for this first symbol 0. For this first symbol 0, the outputs are Q naught and Q1. So here, Q naught, comma, union, delta, Q1, comma, this. Now, purposely, I'm just leaving a space here. Now, first one is 0 completed. First one is 0 completed. Next one is, even though I have an extended transition function starting from Q, we are going to process for this 0. Okay, 0, 0 I have it here. We are going to process for this 0. But where to insert this 0 means in the processing output of this Q naught, comma 0. The previous one is Q naught, Q1, right? That's Q naught, Q1. And then the symbol is 0, hence 0 is equal to Q naught 0, definitely 2 possibilities there, hence Q naught, comma Q1 union Q1 with symbol 0, nothing is there. Sorry, I have nothing is there, so nothing is represented by 5. Hence, the resultant output is Q naught, comma Q1. Now, next step number 4. Extend the transition function initially from Q naught. Symbol is 1, so 0, 0, 1 is equal to delta naught, comma 1 union delta Q1, comma 1. I guess I need not explain this 1 and all because we are processing for 1 here. Okay. Doubt is equal to from the figure currently at Q naught input is 1, then the output is Q naught itself union currently at state Q1 input 1 means performing the transition to Q2. Hence the output are Q comma Q2. Next step number 5. Extended transition function Q naught, comma 0, 0, 1, 0 is equal to, for this one we are going to process here delta Q naught comma 0 union delta Q2 comma 0 is equal to Q naught comma 0. Currently at Q naught, input symbol, two possibilities are there. Hence, both the possibilities need to be written here. And then currently at Q2, input symbol 0, nothing. So phi will be representing nothing. And then Q naught comma Q1. Okay. And then what else? Still one more symbol is there. So step number 6, extended transition function Q naught comma 0, 0, 1, 0, 1. This one we are going to process. So delta Q naught comma 1 union delta Q1 comma 1 is equal to Q naught comma 1. Currently at Q naught, symbol Q naught itself. So Q naught itself, and then at Q1 with input symbol 1, Q2. With input symbol 1, Q2. So the resultant theta Q naught comma Q2. So this is example. So how to process a given symbol? How to a given symbol using not using. How to process a given string with reference to this particular machine means we are going to process it using extended transition. So how we used to process means and result is this one. Okay. So this is the step of explanation result. What explanation bit lengthy, but in future, right, you won't be finding this text lengthy. Okay, will be just for explanation purpose. We're explaining this with example in a very lengthy and brief manner, but it won't happen in future. Okay. Now let's move to this slide. So this union, what is the purpose of this union? And then XA, they are strings, so read by yourself. Try to relate this definition in your textbook with my example so that you're understanding that one very briefly. Okay. Now, this one is this particular, written stuff, whatever they have written, right? The target is to construct a DFA. Given a non-deterministic finite automata, how to convert that one to a deterministic finite automata? That is the process here. And the process name is known as subset construction. Now, certain points are written here. Again, I'm not going to explain these certain points. I'll be straightly considering one example. With that example, explaining how to convert a given non-deterministic finite automata to a deterministic finite automata, and the is known as subset construction. Okay, that's why the term subset is inserted here, subset construction. Now let me take an example. Now we are going to see how to convert a given NFA to a DFA. Okay, this will give to us. This will be provided to us. This is the required one, the converted one. So let me write as the required. Okay. Now let me represent this NFA by the machine M. Let me represent the DFA which is going to be, constructed with reference to the M is represented by M dash. As per the mathematical definition, right, this machine M, which is representing NFA, will be consisting of capital Q, summation, then Q naught, transition function, then F. Okay. Now, based on this, we are going to construct M dash. So M dash also need to have Q dash, and because the input symbol will be same, so no need for the summation and all. initial state also might be different or what we don't know. So we need to assume not dash. Then transition function change. So I have used apostrophe there. And then final state might change. So here. Okay, this is a one. This is the given to us. One more thing. Why the name subset construction being used for constructing a DFA from this NFA means this what is this Q, this initially this will be empty. Initially this will be empty, but in between the process, right, we are going to construct this set of Qs. So I mean the required states in the DFA. So this required these things, right? Q dash will be nothing but 2 to the power Q. 2 to the power Q is nothing but power set. Last class also I have already read the power set from your textbook like that. Okay, all possible state combination for the states is known as power set. So Q dash will be a power set. That's why from there we have the name subset construction. Subset construction. Okay, I've explained this is the provided machine for us, and then this is the required machine to be considered as the DFA, right? Now let me, in order to explain, let me draw the M. M means NFA. Let me draw the NFA. So Q naught. In order to indicate this one is initial state, let me use this A comma B. Q1, B, this is A, this is A, final state, Q2, another final state, Q3, this is B, this is A comma B. M, we are going to derive or construct MDEF. Okay. Now, the steps, once you understand the step, it's very easy to understand. Now, this M was the initial state Q naught. So for this and this, what we need to do is, we need to put Q naught as the initial state in M1. Okay. As per the definition of finite automata, DFA or both DFA or NFA will have only one initial state. That's why Q naught is the initial state for this given NFA. So I'll be keeping this Q naught the same as the initial state for the M dash. Okay, M dash is nothing but DFA. So for the last time, I'm going to mention F dash, M dash is the required DFA. After this, I won't be mentioning it. Now, next one, in order to proceed this next step, let me draw the transition table of this given NFA. So transition table of M. M is nothing but NFA. So let me draw the transition table for this one. A, B, then delta. So initial state Q naught is represented by this. So Q naught, currently at Q naught, symbol A, what are the possible transition option? Q naught and Q1. So let me write Q naught comma Q1. Initially at state Q naught, in symbol B, the same state, Q naught. Okay. Q1 with input B, Q1 itself, then Q1 with, oh, sorry, I've made a mistake. Q1 with input A, Q2. With input B, Q1 itself. Okay. And then next state is Q2. Q2 with input A, Q3. Q2 with input B, Q3. And next one is next one is Q3 with input A, 9, so 5. Q3 with input B, Q2. And then in the case of transition table, right, how to represent the final statements with this asterisk. Okay. So in step number 2, right, we have constructed the transition table of the given M, which is NFA. The same way we have to construct the table, transition table, dash table for M. Okay. So in order to construct this one, right, how to begin means this one means summation A, B. So I have already told in the step number 1, we'll be assuming this Q naught NFA as the initial state for DFA. Now from the transition table from this table 1, Q naught with A input is Q naught comma 1, and then B Q naught. Okay. Now in order to fill the following rows and columns, right, what I need to do is when Q naught is the newly inducted state in the DFA, required DFA, based on this one, A, we are getting Q naught Q1, B, we are getting Q naught. Now, when I check this row, right, Q naught is already here. Q knows with state Q, let me write very clearly. So Q naught Q1 is the new state. I'm going to consider this as the new state. And then what I'm going to do is, let me write it here, comma A is equal to Q naught comma Q1, and then delta Q naught comma B is equal to Q naught. Okay, Q naught is known to us. Known to us means Q naught with A input means this. Q naught with B input means this. So we know the transition path for this Q naught. But this one is new state. So let me write new state 1, or else let me mark this as new state 1. So for this new state 1, right, we need to find the path for both the symbol. For both the symbol with this example means A comma B. So hence let me try to find the new state 1 for this input A. So let me write new state is Q naught comma Q1 A. This is nothing but delta Q naught comma A union delta Q1 comma A. This is equal to, we don't have anything in here in this table, but it has to be constructed based on this table. So Q naught A from this one means Q naught comma Q naught comma Q1 union Q1A. Q1A means Q2. Q1A means Q2. This is equal to union means Q naught comma Q1 comma Q2. Okay, this is again a new state. So let me mark this one as NS2, new state 2. Okay, and then next one, right, for NS1, I mean new state 1, right, we need to find the transition path for both the input, which are A and B. So I need to write Q0 comma Q1 B here is equal to delta Q0 comma B union delta Q1 comma B is equal to Q0 comma B Q0. From this table, Q0 comma B Q0 union Q1 with input B Q1. Q1 is equal to Q0 comma Q1. And then Q0 comma Q1, right? It's already in new state 1, and then we have been finding the transition path for all the input A and B. So this is not a new state. Okay. So this is not a new state. Now, so new state 1 completed finding the input for both the symbols A and B. Now I need to move for this new state number 2. So let me write NS2 for input symbol A. So delta, I have already told if it is more than 5 minutes, then I won't allow anyone. Why 3 students are still trying again and again for entering this class? I won't allow them. Q0 comma Q1 comma Q2 for input symbol. Okay. For input symbol A is equal to delta Q0 comma A union delta Q1 comma A union delta Q2 comma A is equal to Q0 A. Q0 A is Q0 Q1. Q0 A is Q0 comma Q1 union Q1 A. Q1 A. Q1 state Q1 with input A is Q2. Is Q2 union Q2A, state Q2 with input symbol A, Q3. Q3 is equal to Q0 comma Q1 comma Q2 comma Q3. So this is new state. So let me mark this as 3. Okay. Now, next one is for this next state 2, we need to find the transition path for the input symbol B. So this one Q0 comma Q1 comma Q2 B is equal to delta Q0 comma B union delta Q, oh, sorry. Delta Q1 comma B union delta Q2 comma B is equal to Q0 comma B state Q0 with B input Q0. Q0 and then state Q1 with input B Q1. Q1 union state Q2 with input B Q3. Equal to Q0 comma Q1 comma Q3. Okay, let me check whether I have already known this state or not. No, this is new. So let me just mark this as new state 4. Okay. Now, new state 2, finding the transition for input A and B completed. So next one, let me move with new state 3. We need to find the transition for the input A. Q0, comma, Q1, comma, Q2, comma, Q3, A is equal to delta Q0, comma, A union delta Q1, comma, A union delta Q2, comma, A union delta Q3, comma, A. So Q0 A, I'll just copy from here, okay? Q0, comma, A is Q0 Q1. Q0, comma, A is Q0, comma, Q1 union Q1 A is nothing but Q2. Q1 A is nothing but Q2 union Q2 A is nothing but Q3. Q2 A is nothing but Q3. And then Q3A is nothing, pi. So let me just write phi. Let me just write phi here is equal to Q0, comma, Q1, comma, Q2, comma, Q3. I guess this is the new state 3 itself. So this is not the new state. Let me just leave it as it is. Now, next step 3 with input A completed. Next one is next step 3 for the input B. So, Q0, comma, Q1, comma, Q2, comma, Q3, comma, B is equal to delta Q0, comma, B union delta Q1, comma, B union delta Q2, comma, B union delta Q3, comma, B is equal to, for this, let me just try to copy from here. Q0, comma, B is Q0. So let me just write Q0 union Q1, comma, B, Q1. Q1 union Q2, comma, B, Q3. Union Q3, comma, B. State Q3 with input B, Q2. 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 Q0, comma, Q1, comma, Q2, comma, Q3. So it's not a new Q, new state 3 itself. And then next is next state, new state number 4. For new state number 4, we need to find the transition state for both the input A and B. So let me just start it. Q0, Q1, Q3. Next state 4 for the input A, delta Q0, comma, Q1, comma, Q3, A is equal to delta Q0, comma, A union delta Q1, comma, A union delta Q3, comma, A is equal to Q0 A. Q0 A is Q0, comma, Q1. Q0 A is Q0, comma, Q1 union Q1 A is Q2. Q1 A is Q2. Next one is Q3A. Q3A is phi. So let me just write phi union pi. So is equal to Q0, comma, Q1, comma, Q2. Okay, Q2. Next one is, next state 4 for input B. Delta Q naught comma Q1 comma Q3 comma B is equal to delta Q naught B union delta Q1B union delta Q3 comma B is equal to, for B, let me just copy it from here. Q naught union Q1B Q1 union Q3B is Q2 equal to Q naught comma Q1 comma Q2. Okay, so no new state other than this new state 4 is being generated. Now we need to fill the table. Remember this table. We need to fill this table. This particular table, right? Let me fill at the end. So let me construct a new table here. New table means the same. I mean, this has to be filled. I don't have much space here. So let me reconstruct it here. So delta this table 4 A, B, Q naught is the initial state. I mean the same. This one is same. Now how to build the next row means, okay, it starts from here, right? It starts from here. This is new state 1, Q naught Q1. So Q naught Q1 A and B. This is Q naught. This is Q naught Q1 A. This is Q naught Q1 B. So let me just write it. Let me just write it. Q naught comma Q1 is the new state. For the input A, for the input A, for the input A, the output state is, transition state is Q naught Q1 Q2. So I need to write here Q naught Q1 Q2. Q naught Q1 Q2. Okay. And then state Q naught Q1. State Q naught Q1 with input B. The corresponding transition state is Q naught Q1. Q naught Q1. Q naught Q1. Okay, now new step 2. Q naught Q1 Q2. Q naught Q1 Q2. Input A and B is here. Q naught Q1 Q2 I need to write. Q naught Q1 Q2. For this one I need to write Q naught Q1 Q2 for input A. The resultant outputs are 0, 1, 2, 3. Oh, 0, 1, 2, 3. For the input, I mean B, it's 0, 1, 3. B is 0, 1, 3. B is Q1. Now, let me tell you one thing. Instead of moving up and then copying the new state, right? When I scan this row, this Q naught, Q1, Q2, Q3 is new one. So let me just write it here. Automatically it will fold, okay? And then Q naught, Q1, Q3 also new one. Q naught, Q1, Q3. So for this new states, we need to find a transition state for the input A and B. So for that, let me move up. Q naught, Q1, Q2, Q3. A, same. For B also same. So we need to write Q naught, Q1, Q2, Q3, Q0, Q1, Q2, Q3, and then Q0, Q1, Q3. For Q0, Q1, Q3, for input A, Q0, Q1, Q2. Q0, Q1, Q2. Q0, Q1, Q2. And then one more thing, let's move back to the given NFA. In the given NFA, right, Q2 and Q3 are final state. So if you're going to construct a machine, right, we can have one initial state and then we can have more than one final state. So Q2, Q3 are final states, right? So for the new DFA, how to find the final state means, in these states, wherever you find either Q2 or Q3, mark it as final state. Mark it as final state. So Q2 is here, Q2, Q3 both are here, Q3 is here, hence these three are final state. Now again, so all these things, all these states, I mean, these states are nothing but subset of that power set. Hence, the name subset has been derived from this one. Okay. Now, again, we need to draw the diagram. So before, in order to make the look should be a concrete, a definite, a convenient one. For that, what we need to do is, let's assume certain letters for this 1, 2, 3, 4, 5 states. Okay, so let me assume, let us assume state Q naught as capital A. Instead of representing Q naught in the diagram, I'll be representing that one with capital A. And then next one, Q naught comma Q O as B. And then Q naught comma Q1 comma Q2 as C. Q naught comma Q1 comma Q2 comma Q3 as D. Q naught comma Q1 comma Q3 as E. Okay. Now let me rewrite the states. Rewriting delta dash table as follows. Oh, I'm not convinced of my drawings, but not in a proper way. Okay. Now I'm going to draw the diagram. I'm going to draw the diagram based on this. So let me draw the initial state A. The transition diagram of M dash is, will start from the initial state A. Let me indicate this using arrow. For this initial state A, when the input symbol is A, it will perform the transition to B. When the input symbol is A, it will perform the transition to B. And then in initial state A, when the input symbol is B, it will remain the same at A itself. So it means what? Self-loop. So self-loop, let me keep it here as B. So here. Next, when the current state is B, input A, it will perform the transition to C. It will perform the transition to C state. It will perform the transition to C state. If it is A, it will perform the transition to C state. And then if it is B, it will remain in same state as B. So it means self loop, one self loop here, B. Okay. Now next one is C. With input A, it will perform the transition to D. With input A, it will perform the transition to D. D. So presently at C, with input B, it will perform the transition to E. This B, it will perform the transition to E. And then D, self loop. I mean, for A and B, both are self loop. So let me just insert a self loop here, A comma B. And then for E, for both A and B input, it will perform the transition to state C. For both A and B, it will perform the transition to state C. And then what are the final states? C, D, E. C, D, E are final states. C, then D, then E are final state. Now again, let me bring you few points, few differences between NFA and DFA. See here, in the given NFA, right, for a given input symbol A, more than one transition is possible. So in Q naught with input symbol A, there are two possibilities of transition. Either it can be perform the transition from Q naught to Q1, or else it can remain the same in Q naught itself. This is not allowed in the case of DFA. And then in DFA, right, for every, in this particular NFA, in this particular diagram NFA, what are the states? Q naught, Q1, Q2, Q3. So Q naught, Q1, Q3, Q2, Q3, right? We need not check the completeness of the diagram. Completeness means, in the case of DFA, right, every state needs to provide the path for the given symbol. In the case of this NFA, currently at Q naught, the path is being provided for the input A and B. For the state Q1, path is provided for this input symbol A and B. For state Q2, path is being provided for both A and B. For the state Q3, path is being provided for input symbol B, but not for A. This is not allowed in the case of DFA, but this is allowed in the case of NFA. That's why while designing an NFA, right, it's little bit easy compared to DFA. Now let me move back, go ahead with that DFA which has been converted from that NFA. Now, in the case of DFA, right, I have to check the completeness of this machine. Now, completeness means for the given state A, whether I have provided the path for the given inputs. Given input means A and B. So, for the given state A, if the input is A, you can perform the transition from A to B. When the state is A with input B, you can perform the transition in the same state, which is self loop. So it's provided. Now let me check for the state B. For the state B, again, for the symbol A, path is provided. For the symbol B, path is provided. Now for the state C, whether the paths are provided for both A and B, yes. For A, C to D. For B, C to E. So it's provided. For the state D, self loop is provided. It means what? It may be self loop or not, but path is provided for A and B. Now let's check for the state E. Path is provided for both A and B. which will be performing the transition from E to C. So hence this DFA is a complete one and it's correct. So in an exam, if I happens to ask you a few questions regarding DFA, right, these things you need to check. Okay. So now today's class topic is given an NFA, how to convert that NFA to a DFA. It's completed. Now let me move back to the slide. Okay. The slide last part is both are equal. So, I mean, computational power and all both are same. Now this equivalence, right? Let me explain with one term. See, let's see here. What kind of language is being accepted by this machine NFA? This NFA, right? It accepts any language which have any combination of A, B, but in between, if you have double A, it is accepted. It is accepted. And then we have, or else without this A, B, C or A, B combination, right? If it starts with A, and then followed by any combination of A, B, it is being accepted by this machine. And then one more thing, after having this combination, right? Wait a second. Okay, so I have checked that one, and then if the string begins with A, and then followed by any number of B's, and then ending with B or B series, it is being accepted. Okay, so now let me check whether such kind of string is being accepted by this new DFA. Okay, let me just check. So in this example, after reaching this 2A, it is reaching final state and it's being accepted. And then again, after this AA followed by B series, it is being accepted. Yes, B is here. If you are not confident what I have just explained right now, right? You just consider one example. Let's take W. W is equal to A, B, B. Okay, let's see whether it will be accepted by this or not. So let me check A, 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 B, B. Initially, it will start from state A because that is the initial state. Initial state A, input A, this is B, B with input A, this is C, C with input A, this is D, D with input B, D with input B, D is nothing but belongs to set the final state, hence it's being accepted. The string is being accepted by this machine and this. Now let's check for this one and the given NFA. In the given NFA. Okay, now in order to check this one, right, let me rough this because I don't have space. I don't have space, so I need to rough this. Now, let me check the same string. W is equal to A, B, B. A, 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 B, B. Initially Q naught, A. So now, initially at Q naught, two possibilities are there. A, this is, this is Q1, this is Q naught itself. Now Q1A, Q2, then Q2A, Q3, Q3A, Q3B, Q2, Q2B, Q3. Q3 belongs to one of the set of the final states. If you can continue with this one also. Like that you can continue with this part also. But if one of the part is reaching final state, then this is being accepted by this NFA. Okay, so the language accepted by an NFA and DFA both are equal. So that's the end of today's class. And then one more thing, I didn't explain much about this instantaneous description. So maybe in tomorrow's class, I'll be explaining this. Okay. So other part, you just go back and take a few examples of an NFA to DFA conversion and then just do it by yourself. Okay. So thank you for today's class. Wait a second. Okay. Thank you.